Okay, this will be the second video. The lesson that we talked about for the second day was all of these vocabularies that you see on this page. So in this video, we're going to talk about supplementary angles, complementary angles, vertical angles, transversal line, interior alternate angle, and corresponding angle. The last one, we didn't talk about it in class, so my apologies, but we're going to be talking about it in this video. Okay, so let's go here. Now, I think I gave you the notes on this and I asked you guys to write it, but let's talk about again what is supplementary angles. Now, supplementary angles, the dictionary definition would be the two angles add giving you 180 and stuff like that. Well, actually, I really paraphrase a lot. They give you a lot of terms for this, but really what it means is that let's say that there was some angle, angle A, and angle B, that adds to give you 180. So for example, I draw a line, I go like this maybe, call this angle A, call this angle B. This will be an example of, or a pair of angles that is an example of supplementary angles. So supplementary angles have to add to give you 180. If I were to label this as JKLM, please do not say that the supplementary angle is JKM. Supplementary angles has to be pairs of angles that add to give you 180. JKM is just straight up 180. That really has nothing to do with being pairs of angles, right? So what do I say? Well, the angle A and angle B, or to be more technical, it will be JKL, because I'm going JKL, and then, and LM, or LKM, right? And LKM that way. This would be the notation that you would use if I were to give you those letters towards the end. Or if I just label the angles such as A and B, you could just tell me that it's A and B. Now suppose I say that A is equal to 150 degrees. That means that B has to be 30 degrees so that they can add to give you 180, right? Even if I were to give you that A was supposed to be, I don't know, 15 degrees or 115 degrees, then B has to be 65 because they have to add to give you 180. So if in the mathematics term, this would be basically how it's going to be. Now suppose I say that A is equal to 3x and B is equal to, I don't know, let's say 5. So how would I be able to do this? Well, now I'm involving algebra because now I'm calling something else that's called a variable, right? The process of it does not change. You still add them up and equal to 180. But you would just have to do a little bit extra. You just have to solve for x minus 5, because usually the question will ask you to solve for x. You just have to show all this work. Please show the work. I emphasize this many times that the work is more important than the answer. Now that doesn't mean that answers should be wrong. It just means that you also should concentrate on how to do the work here. Divide by 3 on both sides. These cancels out. So 175 divided by 3. Let's do it the old school style. 5, 15, 25, 8, 24, 1, 0, 8. So it's going to give you 58.33. Because this will just keep on giving you tens. Like subtract 9, this, and you're subtracting them, and you're going to get a 1 here, bring down the 0. You know how it goes. So 58.33, and I leave a little dash mark here notating that this will go on forever. Okay? Don't believe me, just use your calculator and just figure out yourself. So this will be the algebra portion that you will be doing if I were to ever give you a question like that. Okay? So recap. Supplementary means it's 180. The two angles add to give you 180. I'm sorry, I pointed out to the wrong thing because that's actually a complete no-no. It's actually this, right? They're the two pairs of angles that add to give you 180. Please don't just give me this. This is no good. Don't just write that one angle is 180. It's a pair of two angles. Again, complementary is the same thing. Now, on the worksheet, there were really not that many complementary worksheet problems on the worksheet. It's particularly because it really has no use other than when we're coming to talk about triangles. You guys are going to be learning about sine, cosine, tangent. Complementary angle will be useful in that case, but right now, complementary angles, you just have to know the two angles that add to give you 90 degrees. So before, supplementary was 180, but now we're talking about complementary, which are two angles, a pair of angles that give you that adds to give you 90. So if I do it again, well, JKLM, your angle JKM is not complementary because there's no two angles that complement each other. This cannot be complementary. The two pairs of angles that are complementary, though, would be JKL, assuming that this is 90 degrees, JKL and the angle LKM, because this angle right here and this angle right here, they will add, the red color plus the blue color will give you 90 degrees. So if I were to say that this angle was A and that this angle was B, then the angle A plus angle B will give you 90 degrees, right? Now let's do a little math for this again. Let's say that I give you that angle A is equal to, I don't know, 30 degrees. Then angle B has to be 60 degrees because they need to add to give you 90. Let's just say that angle A was something like 14 degrees. That means that B has to be 76 degrees because 76 plus 14 gives you 90. Sometimes they did 76 plus 24. Some of the students put 24 down as the answer when it comes to these types of questions. Please check your math. That gives you 100 degrees. So always make sure that it adds to give you 90 degrees. Double check, okay? Because these are very easy problems that when you make a mistake on, 99% of the time is probably going to be a silly mistake. So let's involve some algebra here. Let's say that A was 4x and that B was 1x. How do I solve for x? Well, you just have to add them up and set it equal to 90. So 5x equal to 90 degrees, x equal to 90 divided by 5, or it's going to be the same thing as saying 18 degrees. Or do not say 18, degrees, it's just going to be straight up x is equal to 18 because x is now represented as angles. And that's it. So, short for supplementary, 180 degrees. Comp, short for complementary, 90 degrees. Sounds good, right? After that, we're going to talk about vertical angles. And that was number 3 on our list. For vertical angles, I always told the students to draw two lines like that, like a big elongated X. Now, rather than me telling you what the vertical angle is going to be about, let's use something that we already talked about, particularly supplementary angles. Now, I'm going to call this angle A, call this angle B, and then right here, what we have here is supplementary angles, right? Because this one is a straight up line, and that has to give you 180 degrees in total. So if I know that this one right here, like angle A, so let's say that that's 110 degrees, then B has to be 70 degrees because we know that they combine together to give you a total of 180 degrees. Now suppose I draw this line as blue, and then I draw this angle right here. The blue line should also be 180 degrees because it's the same as red line, it's 180 degrees. So that means that this angle right here should also be 180 degrees. So what does that make this angle? That should also be 110 degrees because the 70 that we got from this one has to add with this angle to combine grand total for 180. And then what can we say? We can say that this angle that we marked as A, which is 110, is the exact same thing as this 110 on the bottom. So even if I were to call, let's say, this angle as C, we know that angle A is equal to angle C. And that is because the property, what is this? This is the property of vertical angles. that they are equal. I like to call vertical angles something as saying facing each other. So as long as the angles are facing each other with two straight lines, they will always equal one another. Now what I'm saying is, let's say that I draw this and then I draw something like this. So you see how there's a little dent here? Like I draw a little dent to indicate that this is not going to be a straight line. As long as you have no straight line, then there's going to be no vertical angles. It's not always the fact that they're always facing each other. It's a matter of having straight lines first, okay? Having straight lines, and then you can say, oh, the two straight lines crosses each other like this and this. As long as they're straight lines, these two angles right here and here, they will always be equal to one another. No straight line, no vertical angles. Got it? So the angles that are facing each other are always going to be equal. So this angle right here will also be 70 degrees because it has to match with this 70 degree side. And the 110 and the 110. So again, if I ask you for a pair of vertical angles, please don't just say J, K, L, M, N, and then you just say like J, K, L or something and just leave it as one angle. It's got to be a pair of vertical angles. So, pair of vertical angles here could be like J, K, L and M, N, N. Or you can write it the other way around, N, K, M. It doesn't matter. As long as it's K should be in the middle either way, right? So that's one pair. The second pair would be L, K, N. L, K, N. And the other one would be J, K, N. Or N, K, J, depending on how you read it. But K has to be in the middle. J, K, N. Give me a pair of angles means I need two angles. A pair. Okay? Let's do some algebra portion or the math portion of this. Suppose I gave you those two straight lines and I tell you that this angle is 95 degrees. Then first of all, what is this angle? That angle has to be 85 because of supplementary. That makes this angle as 95 because this and this are called vertical angles. Now, if I were to give you some algebra portion, such as if I were to give you this as 3x, and then I tell you that this angle right here is 100 degrees, then you know that 3x has to equal 100, so x is equal to just 100 over 3, or 33.33. Because the vertical angles are always equal to each other. Please don't say 3x plus 100 equals 180. This is a big no-no. Why? Because they're not supplementary. They're equal to one another. Supplementary angle will be which one's right here. Like the blue and the red together should give you 180, but I don't know what this is, so I can't solve for it. Or actually, I can solve for it if I have 100, which is just 80 degrees, right? So, whenever I give you vertical angles, it's always going to be equal to each other. That's it. The next one that we're going to talk about is actually all three put together in one. I talked about transversal line. And in that transversal line, two angles that forms from that would be interior alternate and what we call corresponding angle. We just recently learned this. I think it was today. Corresponding angles, interior alternate angles. So, for transversal line, it's kind of like building blocks, 1 step, 2 step, 3 steps. We first talked about the supplementary angle way up here. Very simple stuff. Then we elaborated on that and said, okay, if I extend the lines a little bit and get a little elongated x, then we have vertical angles. Then here, what we're going to have is actually, we're going to have 3 lines. Instead of, this is just 1 line, which is supplementary. Well, this is just extra that you stem off from. 2 lines, I draw like this. And the transversal line will be 3 lines. So how am I going to draw a transversal line? Draw 2 parallel lines indicated with these 2 arrow signs. That's 1, 2, 1, 2. The last line, 3. A diagonal line that just goes through it. So what I like to call this is like your railroad. It's like a rail tracks, right? This would be your railroad. And then this right here, it actually cuts through the rail track, so it's called transversal line because it cuts it through. Okay? So when you do this, you literally create 8 angles. I'm going to notate them for you. I'm going to erase these numbers so there's no confusion. So let's call this angle right here as 1. This angle is 2. That angle is 3. That angle is 4. I'm going to label these as 5, 6, and 7, 8. Now you can probably tell me a lot about angle 1 and angle 2. That is called supplementary. Angle 2 and angle 4 is also the same thing. I mean, there are literally 1, 2, 3, 4, 5, 6, 7, 8, total of 8 supplementary angles that you can create here. Like with these two, 1 and 2 together, 2 and 4 together, 3 and 4 together, and 1 and 3 together. I mean, there are a lot of supplementary angles that you can say. The same thing goes with your vertical angles. The vertical angles, you can say it's going to be 1 and 4 because they're facing each other, right? 2 and 3, they're facing each other. So angle 1 and angle 4 will be vertical angles. Angle 2 and angle 3 will be vertical angles, and so forth and so forth. Okay, that could be done down here as well. Now, complementary angles, as I said, we're not going to talk about it in much length because that comes when it comes around to be triangles. But what I need you to say now is, whenever I give you something like this, you should be able to identify which one is going to be supplementary and which one is going to be vertical angles. Now, let's talk about interior alternate angles. I'm going to redraw this. 1, 2, 3, 4, 5, 6, 7, 8. Interior alternate means, think about the word interior as inside of these 2 tracks. The angle for interior alternate has to be dealing with these 4. It has to be inside of those railroad tracks. And it has to alternate. If I were to take this half of this half right here, and if I were to turn it around, right, this part will stay as 2, 4, 6, 8, but this part that I'm going to rotate around, it will give me like something like this. 7, 5, 3, 1. Do you kind of see that? Just imagine just taking this piece, like cutting it out with like scissors or something. Okay? That's like the little scissors here. And you cut it out, and then you cut this out, and then you rotate it around, and you're basically going to get 7 on the top because that's where it started from the bottom. 5 here, 3 up here, 3 down here, and 1, that was the top one, now it's at the very bottom. So do you see how, if I label it like this, the 4 and here matches with this 5 and they're equal to one another. And the 4 here is located from the original right here. I'm going to erase a couple of these lines because it's going like crazy here. Okay. Okay. Oh. Like that. Okay, so this 4 has to be the same as 5 because I showed you how it translates when you take the half and rotate it around. This word interior came from the fact that it's inside of it, and the word alternate is because it's alternating. It was on this side, now it's on this side. It switched positions, right? So interior alternate angles. Interior alternate angles. There are 2 of them that I could see, is 4 and 5, or 3 and 6. Because 3 and 6 is the same reason. This angle now rotated around to become this. Same that happens here, because they have to equal each other, right? So interior alternate angles is whatever's inside of these tracks, and they're switching, they're changing its location, versus what we call corresponding angles. Now, if we're talking about corresponding angles, what I told you today was that it's the same shaped angles. So for example, I'm going to erase these red, blue marks here. This is 5. So corresponding angles, it looks the same. If I gave you this right here, just this portion, and I don't focus on this right now, just focus on this. The 4 and the 6, well, I'm sorry, not 4. The 2, this angle right here, 2, and the 6 would be what we call corresponding angles. Do you see how their angles look exactly the same like this? Like it's this shape. If I were to give it like a cone shape like this, they're the same shape, right? For interior alternate, it switched positions so they look different. One of them looked like this, the other than look like that. So they have the same shape for corresponding angles, and the corresponding angles, like the word says, corresponding, it corresponds to whichever location it was, but it's on different floors. So like let's call this like the first floor, and let's call this like the second floor. So instead of using it as a railroad track analogy, use it as a floor analogy where this is your first floor and this is your second floor. Now on your first floor, this is where you are. Now on the second floor, this is where you are. You're literally translating yourself upwards by one floor, and you're still located in the same spot, right? So that's what it means to be corresponding. Your corresponding location is the same, except that you're in just different levels. So what would that be, for example? So if I redraw this, 1, 2, 3, 4, 5, 6, 7, 8, this angle 2, this angle 6 would be called corresponding angles. What else? This 5 right here. Oh my god. Okay. So this 5 right here and this 1 right here would be also called corresponding angles. This 8 with this 4, because there's the same location, just different levels, right? 4 and 8, they're on corresponding angles. And look how the 8 looks like this, and the 4 also looks like that. It looks like the same shape, right? The last one, you guys can probably tell, 7 and 3. So they're a total of 4 corresponding angles. The order doesn't matter. You can write angle 3 and angle 7. It doesn't matter, right? As long as you have the pair, that's the same. A pair, okay? A pair. That means you need to give me 2. Okay? So that's a major difference between interior alternate. Think of the tracks inside of it. Corresponding angles. That same position on 2 different levels. Okay? All right.